So for the disability simulation, I went under the tab Mathematics and chose the spatial activity with making 3D inferences. So this was the question I was given. Pretty much if you take this square piece of paper and sliced what to me looked like a cube in half, what shape would you get? I obviously chose this, the B. It seemed very obvious to me. And despite I knew that was probably not the answer, right? Because this is a stimulation to make you feel differently, and I don't have any issues with math. So I knew A was probably the answer. So I looked at it and I honestly could not figure out how that could be the answer. So in fact, I was wrong and A was the answer. And I was still, even knowing this, I was still confused on how that was the answer. So here's the why. So you have what it looks like a cube, right? But it's actually just a bird's eye view of this pyramid, pentagon looking shape, right? I'm sorry, I'm bad with math terminology. And then you slice it, right? And you get that from a bird's eye view. So this was obviously very, it was kind of like mind opening, or kind of like a mind like, whoa, how did I not see that before once it was explained to me? But I'm just so used to seeing that representing a cube. So I guess it just kind of like opens your mind for how this stimulation helped me better understand a student with a disability in this area. It just kind of it helps you see that what you see isn't what everybody else sees, and what you experience and what you feel isn't necessarily what your student feels. So I think it's really important. I'm actually taking a math education class right now. And the biggest thing I've kind of taken away from this is to understand. It's so important to understand why students get the question quote unquote wrong, and a lot of times my instructor just kind of says it's not about, students aren't always wrong. Like, even if they're wrong, the textbook answer is wrong. It's important to know why, because they might be right. And for example, for me, when I got the answer wrong, but to me I was right. And I was right in thinking what I was thinking was right. It's probably very confusing, but I hope you understand what I mean. So as I went through the simulation, what were the things that I wish I had? Okay, so for this simulation, I think seeing it on a flat screen made it very difficult. So I'm trying to see a 3-dimensional item on a 2-dimensional screen. So I think having a concrete example of it, so with the actual real 3D shape, would have really helped me understand and get the answer right. Or even a 3D representation on the screen that is virtual, so it moves around so you can see all the edges and really understand it. But definitely with a flat screen, there is no way that I would have gotten that answer right with just looking at a 3-dimensional item on a 2-dimensional surface. So as far as this, kind of, I touched on this before, but how will this simulation kind of help me and think as a teacher for all students? Just again, just because you know the answer and what you think is right and it comes to you naturally, I think it's so important to really get inside of a kid's head and understand why they think the answer that they had is right. Because a lot of times there is a logical reasoning for why they get answers. And if you can get inside and understand why they had that answer, one, you can validate them for thinking critically and trying. And then secondly, you can explain to them how to think about it instead, and figure out why they're struggling. So I just think it's really important to understand the why and why students are struggling or getting an answer wrong, because that's really, as a teacher, I think that's kind of one of the most important jobs, is to find why, not just if a student is failing. Is your job is not to give the grade, but to figure out why they have that grade, um, and to help them have better grades. So that's my thoughts on it. Thanks for listening. I'm really interested to hear what you guys have to say about